It was extremely early in the morning. We were all waiting for the stopwatch to hit 0, and as soon as it did, I could see the engines ignite and slowly push the space shuttle up into the air. I was 5 years old at the time, and my family had driven to Cape Canaveral to see the last of the nighttime space shuttle launches. The main propulsion system is the reason why the space shuttle even worked in the first place. I will discuss the three main segments of the system. These segments are the external fuel tank, the solid rocket boosters, and the main engines. The first segment is the external fuel tank, which is this piece right here, and everything else, including the shuttle itself, attaches to the external fuel tank. The fuel tank consists of two fuel tanks and a intertank to separate the two. The first of the tanks holds liquid hydrogen, whereas the other holds liquid oxygen. The inner tank holds processing equipment and supports the other segments. The external fuel tank also has attachment points for other segments. For instance, the solid rocket boosters connect to either side of the fuel tank. And the back of the tank contains the bipod and attachments for the space shuttle, or the orbiter as we know it. The next section is the solid rocket boosters, which attach to either side of the external fuel tank. These boosters produce 5,300,000 pounds of thrust at sea level, according to a NASA article called "The Space Shuttle Solid Rocket Boosters." The fuel that is used in these boosters is actually powdered aluminum and ammonium perchlorate. These huge boosters start out by the fuel being mixed in 600-gallon bowls in a plant in Utah, according to the NASA article, "The Space Shuttle Solid Rocket Boosters." The fuel is then poured into the casting segments and left to cool and harden. The castings are then assembled to form the finished boosters. At the base of the booster is the thrust cone, which also acts as a thrust vector control cone. The separation, recovery, thrust vector control, and other systems are also all held within the solid rocket boosters, mostly at the top of them. The last segment of the propulsion system are the main engines, which are a grouping of three Rocketdyne RS-25 rocket engines. Each of these engines produces 375,000 pounds of thrust, according to the NASA article, "The Space Shuttle Main Engines." These main engines burn 500,000 gallons of fuel each mission. Each of the engines is attached to the orbiter on separate mounts, which also pivot to control the shuttle during ascent. Also, the back of the orbiter has fuel lines coming out of it to attach to the engines. These fuel lines then go through the orbiter and connect to the external tank. These engines were all reusable, and they were reused on multiple shuttle missions over the 30 years of the shuttle's existence. I discussed the three main segments of the space shuttle propulsion system. The external tank is the backbone of the shuttle, and all of the other segments connect to it. The solid rocket boosters are attached to either side of the external tank, and the main engines are attached to the back of the orbiter on separate mounts. The space shuttle is an amazing feat of engineering and was used by NASA for 30 years. Thank you.